Great. So this is serverless on your own servers, which is kind of a clickbaity title. But anyway, I'm going to talk. Oop. Am I echoing too much, or is it all good? OK, great. So I'm going to talk a little bit about what I see serverless as being, and talk a little bit about some properties that serverless applications or platforms have, and how you can take existing software that you've got and through work, it's not going to be easy, but you can make your platform more serverless and more enjoyable for your users. Because really that's why you're here and doing this, is that you want your users to use your software a lot and recommend it to everyone else and to have a wild, crazy success. So some people have heard me rant about this already, but serverless is a terrible name because it talks a lot about what it isn't and not about what it is. And it's not true because there really are servers. And so the first argument everyone wants to have is, but there's really servers there. And that completely misses the point. Yes, there are servers there. Yes, your code runs on servers. Most of your code. Some of you are working on client-side things too, and there isn't quite the same thing for client-side things as there is serverless right now. But there are a bunch of developments on the client side which I'm not going to talk about much today because I'm not, frankly, the best qualified person to talk about it. To give you more of the same flavor of experience that I'm going to talk about here. So there are a couple different ways that people choose to define serverless platforms. The one that I like, and this is the one that I'm going to focus on, is that you have a development model where developers focus on doing a single unit of work well. So they don't think about connection pooling and instance counts and auto-scaling and how things get cloned. They think, run this function, answer this HTTP request. And we'll talk about some of the other things that are single units of work in a minute or two. Related to this is having a platform which automatically scales without developers or operators needing to get involved. So these aren't the same thing. They're related, though. If developers are focusing on a single unit of work, someone's still got to be doing that scaling. And either you have an operations team running around in the background frantically trying to keep up with what the developers are doing, and the developers aren't communicating with the ops people. And that kind of sounds like where we were 20 years ago before this whole DevOps thing. Let's not go back there. So if the developers aren't going to be doing the scaling and the operators aren't going to be doing the scaling, the platform has to do the scaling. And then the last definition that lots of people like to harp on, particularly if they are hyperscalers trying to sell you a particular product, is that you pay for what you use. So if you use 10 seconds of compute, you pay for 10 seconds of compute. You don't pay for the time it takes to boot your instance and the time that it takes to shut things down in some minimum increments and things like that. But I'm most interested in the first one because focusing on a developer model where the developers focus on a single unit of work lets you build that second one because the developers aren't thinking about scaling and so forth. And if you've built your platform right, they don't have to think about it because you're doing it for them. So what is that single unit of work? Well, I talked about function as a service a bit before. So that's run this function once. It could be Lambda, it could be Cloud Functions, it could be OpenWhisk. But you basically say, here's a function, you can run it as many times as you want. They're all independent of each other. It doesn't keep any state. This is awesome for infrastructure builders because it doesn't keep any state and it lives for 60 seconds is basically easy mode. You can be like, hey, I made this thing, I ran it, and now I can just throw it away. I don't have to worry about it. I can reuse it. Nobody cares. But basically, I've made the developers figure out all the hard state stuff elsewhere. And I've said, I'll take care of the easy stuff. Let me do the easy stuff really well. You focus on the hard stuff that may be too hard for me to understand generally. But it's a great place to start. Obviously, this is the hot space. If you're here at the Serverless Practitioner Summit, you've probably heard of Lambda. You probably know that Lambda is, this crazy gangbusters thing in the serverless world. Build. A lot of people use Travis, use Circle. It's serverless. You don't know. Well, OK, it should be serverless. There may be cases where you discover where abstractions leak through. We're going to talk about that later. But ideally, you say, hey, build this thing. Here's my instructions for building it. You do it. You figure out how to pipeline builds, when to run them, and so forth. I just think about how do I build my software? And then I write a description, and I hand it to you. And then you take care of doing the building. Maybe all the building happens on a single machine. Maybe you parallelize it. The point is, as a developer, I don't care. I care maybe how fast my builds get done. And I choose between services based on that. Or maybe how much it costs I can choose between. But mostly I'm choosing on the features, does it do what I need? And there's lots of examples of this. A fun one that I like to talk about because I work at Google and it's the bee's knees is Google BigQuery. So if you haven't used BigQuery before, it's kind of an amazing fire-breathing thing. Who here would run a regex expression on your SQL database? Just select where regex match, this string. It turns out BigQuery eats this stuff up. You can have like 10 terabytes, 50 terabytes, a petabyte of data, and it's organized, in sort of a protocol buffer inspired model. And you can just feed it these queries, and it will figure out how to parallelize it and make it go fast. And it even has stuff like user-defined functions. And the way it works behind the scenes is it breaks out the work to a bunch of individual workers. But your interface is run this SQL query and give me the answers. And it'll come back, in 5 or 6 seconds, and tell you, hey, I searched, 3 terabytes of data, and here's your answer. So it's probably clear why MySQL and Postgres don't quite meet up to that right now. Even with something like Vitesse, you have to think about the sharding in your shard keys and so forth. If you can show me a database that can do that sharding automatically for transactional stuff, I'm super interested. BigQuery is mostly import your data and then run read queries. So I don't have a great answer for you for a serverless, write database with a SQL interface. Google Spanner gets kind of close, but you still see the instances underneath and how many you provision and stuff like that. Object storage. Probably actually one of the original serverless services. And nobody thinks of it as serverless. Nobody talks about, oh, S3 is serverless. But hey, I've got a back end. Ooh, OK, no yelling, even if I get excited. Hey, I want a folder, a remote filer, and I can just throw as much stuff into it as I want, and it just gets bigger and bigger and bigger for me. And I don't have to think about it. That's totally serverless. And yeah, you can just keep throwing things in, you put it where you want, and you pay for the storage when you're using it. So it even meets that last definition. So I've talked a bunch about this focus on one unit of work. Why, though? Well, which do we care more about for most projects? The cost of the developers or the cost of the hardware? For most projects, it's going to be the cost of the developers. And if you do end up with one of those wildly successful projects where your hardware costs start to eclipse the cost of your developers, the models that you've built up from using serverless will actually help you scale it, because it scales horizontally really wide. And then you pay 1 or 2 people to dig down in and figure out how to make a single function run faster. And look, your hardware costs get reduced. It's like magic. So serverless is great for this kind of thing, for both your costs and your developer productivity. But the key thing is the developer productivity. And this applies to your operators, too. So this is I can't share you numbers from Google, sorry. So this is a back of the envelope using AWS as a hypothetical, and EC2 in particular. EC2s, when you do get really big, their hardware costs are much bigger to run a server for a year than $400 for the engineer to do it. So when you get really big, you want to make all your work units the same. So saying, here's a unit of work, helps you when you're really big, keep your ops costs low. Because you're no longer saying, oh, here are 70 different things, each of which needs a team of 20 engineers because they're big enough to need 1,000 servers. You say, oh, I need 100,000 servers, and they all work basically the same. So instead of 50 teams of 5 ops people, I'm going to hire 60 or 80 people, and they'll manage all of that stuff the same way. And serverless gives you that power because your developers are focused on all using the same deployment model, the same release model, and so forth. Kubernetes gives you this too. Kubernetes is basically a cluster operating system for your operators. So it's not really a surprise when you get big that you start caring about this stuff. But the real reason for focusing on a single unit of work is that it cuts down on your distractions. And it lets the platform take care of a lot of these things. So, right off the bat, if you're using a serverless solution, you don't have to think about capacity and replication and sharding on an individual service basis. You can have a stamped out pattern that does that. You probably get the same thing for OS and library patching because you're running on standardized OS images. You may have to come up with a Docker patching solution if you're building on Kubernetes. But it should be a consistent one across all the different containers that you run. And so, hey, look, there's a new vulnerability in OpenSSL. Well, that sounds really bad. What containers do I have that contain OpenSSL? Oh, it's all of them. Surprise. But at least now I know what I need to rebuild, and it's not like, oh, so these 50 servers, I need to run a yum update, and these 20, I need to do an apt-get update, and these 7 over here, I have to wait for the upstream, vendor patches or whatever. You've got a consistent way of building these things. Focus on one thing. When you've got individual units of work, your testing can become easier. Test one thing, define its interface, and then you can just test that one thing. And yes, you still sometimes need to do integration testing. Depending on your rollout controls, rollback may be faster than a complicated integration test suite. And that may be the right choice in some cases. I read an interesting article recently from someone who was at Facebook in 2013 and said, they wrote a bunch of unit tests and they promptly got deleted when they broke because the solution was just roll back to the previous working version on the site, flag guard everything. And if you do that, then, if anything breaks, your metrics tell you, you roll back immediately, and then you figure out what went wrong after that. So having a standardized solution lets you do things like that, which you can build outside of the unit of work. And you can say, hey, here's the old unit of work, here's the new unit of work. We're going to canary it, we're going to see what happens, and then we're going to roll back if needed. Can help a lot. And then there's always going to be overhead stuff of things like outages and bug triage and things like that that people won't be able to get out of. But at least you can take a bunch of the daily grind out. So what does it take to get there? So if you're building one of these platforms, you need to understand what it is that developers really want to do, how they want to use it. So the really interesting thing about Lambda is saying you want to do exactly one function. You want to do exactly one invocation. There's other models that work. So I've got on the first row for general purpose computing, OpenFAS, Apache Beam. Might not think of it as a service solution, but it's, hey, write one description of how you want to process your data, and then you can do that. Someone else could potentially do the tuning. I don't know that Beam is great where it is right now, but I think that's where it's going, and that's where it should be going, is just write the description of how you want to process your data. Someone else will figure out how to fit that onto the machines and do the planning. It's like a SQL query planner for your big data. And then Google's Cloud Run. If you're storing data, it depends on what you're using it for. If it's mostly for human beings doing reports or asking questions, if you're doing observability, if you're doing business analytics or something like that, then your API should be something that's friendly and approachable to humans like SQL. If it's mostly intended for machines to read it, maybe pick something really simple. I'm not going to hold Redis out there as the, hey, this is a perfect thing. But if you look at their tools and their language and so forth for connecting to things, it's all based on the idea that machines are going to be doing this querying, not people. Object stores are kind of a mix of both. You can pick those names so they're meaningful to people, but you can also just be like, oh, I'm going to put a UUID on this and upload it to a bucket. And I'm going to have a bucket full of UUIDs. And when a human opens it, they'll be like, my eyes! But if it's for computers, then that's a perfectly good interface. And I've got Kafka in there as another interface, which is basically, on one side, on the producer side, it's push things onto a queue, and on the consumer side, it's take things up to here off of the queue. And then there's other times. Sometimes you're building a platform where your goal is to be glue. Your goal is to stick things together. If that's the case, your goal is for users not to think about you. Sorry. You're going to have the awesomest thing ever that no one ever talks about. Like the shell pipe, that little bar. Super awesome, super useful. When was the last time you heard someone say, oh man, I love that pipe thing in Bash? Your goal is to get out of the way. People shouldn't be thinking about you. They should be thinking about the stuff they want to glue together. And so, I'm not sure that we're doing a great job there. I've got Circle and AWS Step Functions as some examples of places where maybe we're moving in the right direction. I think Circle and some of these other build things are actually further along than we are elsewhere. If a lot of you are using Terraform, I don't know how much time you spend thinking about Terraform and how Terraform's going to work as opposed to the pieces you want to stick together. But if you're building one of these glue tools, think about how you get out of the way. How do you make it so that people can just do things elsewhere? I've seen really cool things with, for example, Java annotations to extract out the structure. So if you're working in Java, you can just annotate your stuff and run a preprocessor. And then you're thinking in Java. You're not thinking in the glue that ends up sticking your stuff together. If you're trying to be serverless, multi-tenancy helps. You don't need it, but a lot of the patterns that you need for multi-tenancy end up also being good for serverless. So services over a network. I've got a pool of servers, and I can add a new partition to it without needing to add more servers. That mapping is fluid. That's really helpful for a serverless solution because things will start out small, and then they should just be able to grow without people having to go and file a ticket or something like that. Just start taking up the remaining space. And being able to scale those back-end resources without needing to tell the clients, oh, hey, guess what? That partition you were talking to, now it has 7 servers, not 6. You wrote a bunch of data. Now you need to keep track of more servers. And now, oh, you wrote more data. Now we're up to 12. If your clients have to know that and encode it in some way, then that makes things less serverless and a little harder for people to work with. So in Knative, on the control plane side of things, on the management side of things, we talked about what are the user journeys when people do have to go and interact with our API when they're not just thinking about writing their code. And so we came up with 4. You're deploying for the first time, you've got nothing there, tabula rasa. You had something, and now you need to move to a new state, so there's a transition and you need to update. Coming from SRE, this next one was very important to me. There's a problem or an outage, and you need to roll back. How do you make that quick and reliable? And your first reaction when there's a problem is, let's go back to the old code that was working yesterday. And then as you get more advanced, you may end up wanting to say, hey, let's not knife switch our whole site over to the new code. let's take 1% and see how that works. Let's take 5%, see how that works, and do canarying and staged rollouts and percentages. And so by talking about these journeys, we talked about how to make them each be one API call so that when you run the command on the client, either it commits or it doesn't. And we thought about that when we thought about our API. So taking Kafka as an example of something that could be kind of serverless, your options are push and pop off of this persistent queue. Your partitions don't map one-to-one to servers. So you can say, hey, I've got this topic. It's got 1,000 partitions. That's way more than I think I'll need. But if it gets big, I won't have to repartition. That's awesome. And so that micro-partitioning lets people, OK, assign something to 1,000 partitions or 5,000 partitions. And then as it grows, the partitions get fuller, but they never get so full that they cause a problem. And you just add more servers to back things up. And different topics enable that multi-tenancy we talked about. You can have 10 different topics backed by the same set of 3 servers. And so as you add more servers, things balance out onto them. So what's not so serverless about Kafka? Right now, there's some pretty solid limits. If you start doing micro-partitioning, you discover that N, the number of brokers, and the replication starts to actually put a damper on how many topics you could have. If you were like, oh, we're going to do 10,000 partitions for every topic, so we don't have to ever think about resharding. The numbers I saw were you'd get maybe 20 topics or so per Kafka cluster, which might be smaller than you'd like. The failover semantics make you think a lot about individual nodes. There's a coordinator, and if the coordinator fails, your recovery time is based on all of these partitions and so forth that you made and how the coordinator works. And ideally, that would be something where you had a master or a primary or some sort of leader election that had a quick failover and someone else knew the state right away. But they're working on stuff like that. And the cluster address is a little weird. You need to know somebody who's participating as one of the servers, and then they'll tell you the other ones. And it would be nice if you could just give a network name. But I think the last I checked, if you give multiple A records, it doesn't actually figure out, oh, try one of these. If it doesn't work, try another. But obviously, these are things you can fix. So I'm getting close to wrapping up, in case you're getting tired of this. But not everything is serverless. It's hard to make some things serverless. And it only works building a platform if you understand how to break things down into those separable units. So a great example that I don't know how to make serverless is if you like to play action games in multiplayer, something like Fortnite, and everybody's interacting with each other. That's usually going to a single server where it's doing a bunch of operations in memory, and it might be working at a 60 hertz tick, which means they've got 16 milliseconds to manage where everyone's moving and figure it and send it all back out. I don't know how to make that something where it's just like, oh, you stretch it horizontally, and all of a sudden you don't have to think about memory access times. No, that's not going to work. So there's some places where serverless doesn't fit. That's OK. But if you understand your problem and you can say, and if you go over and talk to some of the Agonies folks at Google, they have a mechanism for at least making it easy to run many of those game servers and assign users to a particular game server. So it's moving in a serverless direction, just not quite as completely serverless as you might like. And there's actually a whole bunch of different things in that game server example that tick off basically all these boxes. Scales out in server units. Your client needs to be talking to your server. If you talk to some other person's server, weird things happen. You need that stickiness. And you end up with, settings that are basically shared across all of those different things. So this is the part at the end where I give you a call to action. I don't know how many people here are application developers versus platform operations teams, and who's here writing infrastructure software. I wear that last hat. And so I'm thinking about how do I make the stuff I interact with more serverless. From a build point of view, if you're an application developer, you're giving me that demand. You're saying, hey, I want something that's more serverless. Tell the people who are buying your infrastructure, hey, I want something that looks more like this serverless where I only do one unit of work and I don't get distracted by all the other things that need to happen in the business. Let the platform sort that out. If necessary, let operations sort that out. But I want to be able to just focus on my code. And if you're on a platformed team, look for the software that you can give to your application developers that will do that without costing you an arm and a leg in terms of staff and ticket volume and burnout and things like that. If you're on one of those platform teams, you're really the glue between those of us writing infrastructure and those of us consuming infrastructure. And that's all I've got.
Do we have any questions for Evan? We have 10 minutes to fill.
Here we go.
Hi.
Yeah.
So with the move from a monolith to microservices, things were pretty much easier for developers to figure out how do I make my solution look like. However, with serverless, it's more or less black magic that's hidden somewhere, and there's no much prior art about it, or yeah. So how do you see that developing? Actually, how to do old style use cases like my next ERP system in a serverless fashion?
Well, I think, so I don't understand a full ERP system, but I think serverless and microservices actually fit together pretty well. Microservices, a monolith is basically, oh, I've got one thing, and by the way, it does these 50 different things. Oh, and they're all complicated. They're not just like a one-line description. They're like 2 pages of text describing what this, what one of these 50 things is. So microservices basically says, why don't we break that up into 50 different things, each of which has a 2-page description, because your business is complicated, not because we hate people or something like that, but because let's say you're doing insurance, for example. There's a bunch of rules about what you can insure and how, and maybe it varies by city or by state. Maybe there's taxes that need to be built in. Like, that's a thing that, that complication's not going to go away. We live in a complicated world, and the thing that kind of annoys me when people show the serverless stuff is they're like, look, you can do this 10-line function. And it's like, yes, but people's problems are bigger than that. But microservices let you at least break that monolith into 50 separate things and hopefully have some sort of interface between them. And then for the things that make sense, you can run them on some sort of serverless platform. You can say, hey, this microservice has a backing database, and then all of the application logic can be stateless. Or, hey, this entire service looks like an enriched key value store. So if you had a key value store where you can run some compute alongside the data storage, so whenever you say store, you get to run a little bit of code. That would be a serverless thing. I don't have a great example of a thing that is alive and other than the mill wheel paper from Google, which nobody else can use. So I can reference it, you can read it, it's interesting, but the idea is basically you can run a little compute alongside each storage node and react to stuff. And that might be the right serverless thing, and maybe someone should build it. It's on my list. I've got a long list. But yeah, each microservice should make its own choice on serverless. I would encourage them to choose something serverless, but maybe there's something where that doesn't work. Maybe all the data needs to come together and be a big knot somewhere. And then maybe you buy the biggest machine you can. But for the other 49, you've got hope. One over here and one over here.
I noticed that you didn't talk about scale to zero, but if you read a lot of serverless, even Knative, scale to zero becomes a key talking point. What is your view on that?
Could you elaborate just a little more?
The fact that, for example, in Knative, you go to 0 containers if there's no load.
Scale to zero, yeah.
Scale to zero, yeah. Is
Um,
that critical in your theory of serverless or not?
No. Let me scoot back just a little bit to my section on multi-tenancy, and you'll note that I say it's okay to fake it, particularly if you're starting. Maybe you don't actually scale to 0, but your resources get pretty small, and maybe you like take a server and you chop it up into 20 different pieces, and then somebody else is only using a 20th of a server, or a 50th. Ideally, you can stop using most of those resources, but there's always going to be something hanging out. True 0, I don't believe it.
Actually, I'm gonna push a little bit more on this issue, because the question that I have, and maybe you can answer or somebody else, is how important is it, from a point of view of cost, and even if you do back of the envelope calculation of something like scale to 0. And the reason I say this is because I keep hearing from folks from IBM that the cost of running these massive data centers is electricity. Initially, you have some cost to buy the hardware, right? Okay, so if that's true, and you think, okay, well, what burns the most electricity on a machine? It's typically CPU. And why? Because it just generates energy. And if you are, assuming like 50% of your workloads could go down to 0, I'm imagining that it's going to reduce the amount of CPU usage, which would reduce the amount of electricity. So is there some calculation in there that could tell me, like, okay, by reducing to 0 very aggressively, you're saving, on average, maybe amortize 20% of your cost?
Sure. I can do a quick ballpark based on GCE compute costs. So the question is, okay, how much are you saving? Let's say you've got an application version, and you keep 2 or 3 versions around, and you don't scale to 0, you only scale to 1. And you size things so it only takes half a CPU. And it takes only like 1.5 gigs of RAM when it's sitting around resident. Each one of those things over the course of a month on GCE is going to cost you about $15. How many $15 do you need to pay for a month of an ops person time?
How much of that $15 is electricity versus, let's say, the overhead of people?
I
You
can't
share that one?
answer that for you. For a bunch of different reasons. I don't actually have the numbers, and I suspect they're proprietary if I did have them.
But is it significant? Is it non-negligible?
It's a non-negligible amount of electricity. There's also, cooling and other things like that going on as well. There's actual staff, like that $400 a year per server. That's getting split out across 32 or 40 cores or something like that. But that still ends up being like $1 a month. So there's a lot of different costs that go in. Electricity is one part of it. If you can scale down to 0, that's nice. Across a fleet of, say, 1,000 applications, that's $15,000 a month. That's not too bad. On the other hand, you also have 1,000 applications. How much is that going to cost to run if the servers were free? The people running it aren't.
Is it also fair to say that serverless is good for the environment, for the planet? Maybe that's a stretch.
I think that's a bit of a stretch to say that serverless is on its own good for the environment. I don't think it's bad. It helps you push up that hardware usage number. But in most cases, if you get to virtualization and oversubscription, your hardware costs are probably not going to change by more than maybe 50% when you put in serverless and scale to 0, would be my intuition. I'd love it if somebody actually had studied that and it wasn't just me pulling numbers out of wherever.
May I have time for one more question? Anybody else? All right, in that case, thank you, Evan.
Oh, I'll also say, in terms of the environment thing, that at least Google's data centers are all renewable energy powered, so there's that.
All right, thank you.